Hi to everybody. We are on the testing of a transformers part 5. Testing is a very much important in the life of a transformer. Testing, why it has to be done, when it has to be done, what are the importance of the testing we will discuss in this particular one. I am J N Karamchetti. I am a graduate in electrical engineering from JNTU Kakinada. I have done my MTech from IIT Kharagpur and I have a diploma in business and finance from ICFA, and I am a certified energy auditor from BGE. I am a master trainer in rooftop solar grid engineer, NISC and MNRE, and my experience is industrial experience from the development engineer to chief executive officer in public limited companies for about 37 years, and training of engineers. I have been doing it for the last 10 years at Engineering Staff College of India. And participants for that is from the power utilities as well as from the industries, experienced people with about 10 years to 25 years. And I was also conducting training programs for the junior engineers who are joining in the organization as a graduate engineering trainees. They need more fundamentals to be taught, which I have been doing it. So they have been doing very well in the last 10 years. Coming to the subject, the objectives of the module development is: the author is a qualified, experienced electrical engineer, power electronics and energy conservation and auditing. Design and implementation of solar photovoltaic power plants and theory power plants. So I have a lot of a theoretical and practical knowledge, engineering professionals to improve their skills and in turn to develop India. So I request all of you to pay attention and read it more number of times to get experience on this. All these modules are connected with the practice only what I have been doing it for the last 10 years. Now, why transformer testing is always a question. Let us answer this. Need for testing is to ensure that the client gets the required and meeting the specifications for the price he is going to pay for that. That is a very important, meeting the specifications. Specifications some client gives, some are statutory. Regarding the safety, they are all statutory. And client tells that I need 11 kV transformer on the primary side or 22 or 33, and the secondary side he requires a 433 volts mostly, 3-phase, 4-wire system, and neutral brought out so that the neutral can be connected to here. So they are all important thing and one has to read it. To provide an effective tool to ensure quality and conforms to the design calculations. This is also very important one need for testing. Now, to determine the transformer's electrical, thermal and mechanical suitability. Now, electrically, primary voltage, secondary voltage and the load current is electrically. Thermally, how much is the temperature rising, whether transformer oil is sufficient to cool for that, or the body is sufficient, or the systems provided for the cooling, ONAN or any forced cooling or whatever may be, is it thermally suitable so that the transformer temperature is not increasing beyond the design level. That is important. Mechanical is whenever there is a short circuit outside the transformer, transformer has to supply the short circuit current. So there is a lot of a stress on the transformer windings inside. The winding should not give away and damage the transformer. And in case of a bigger transformers, when it is transported from one place to another place, especially hilly places, the transformer gets all the vibrations on the roadside and it may hit the trees also. The transformer is delivered to you without informing all this. So there can be a mechanical damage inside the transformer without seeing outside. So they are all to be tested first to see that the transformer is meeting our requirement. And industries and the power systems where it is used. Now, tests on the transformer basic requirements. A test shall be made at any ambient temperature below 50 degrees centigrade. Application standards will be either IEC for international or Bureau of Indian Standards, and all external components, its fittings that are likely to affect the performance during the testing shall be placed. That means there are so many components coming outside the transformer, they all should be fitted and then tested wherever they require. In case of a bigger transformer, let us say 10 MVA and above, they can't be fitted, so manufacturer has to go there After the transformer is fitted, he has to send his commissioning engineer and test all that and hand over the transformer. Now, transformer testing. One is a routine testing, another is a type testing, another is a special other tests. Please understand one thing. When you are releasing a purchasing order, all this information has to be written in the purchase order. What tests has to be done free of cost as a part of the transformer, and what are the tests to which you have to pay. If you do not know about this, manufacturer may omit that. So it will be a burden for you after the purchase. Now, what is meant by routine test? Routine test is done on all the pieces manufactured. Whereas a type test or a design test is if you are buying 100 transformer, he will test one transformer. If you need another some of the other tests called a special and other tests, the seller will charge for them and you have to pay for them also. One more important thing is finally whatever the certificate is given to you, you have to keep the certificates till the end of the transformer life. Many parameters required in that you have to measure, test it at frequent intervals, see that the parameters are remaining the same throughout the life of the transformer. Basics of the transformer, the invention of power transformer toward the end of the 19th century made possible the development of modern constant voltage AC supply with power stations often located many miles from the centers of the load. Now, a transformer is a static piece of apparatus used for transferring power from one circuit to another without change of frequency. It can raise or lower the voltage with a corresponding decrease or increase in the current. That means VI will be constant. We can buy either a step-up transformer or step-down transformer as per our requirement. In its simplest form, transformer consisting of two conducting coils having a mutual impedance. That is an important thing is there is a mutual impedance. The primary winding is where it receives the electrical power and the secondary winding is the one which delivers the power. A transformer is an important vital equipment. It is therefore necessary to ensure its proper performance throughout its service life. One is failure has to be come down so that the transformer is reliable to you, and the energy consumption has also to be minimum because you have to pay the wastages also to the electricity department for the 25 years of its life. It is necessary to do a factory testing prior to dispatch to ensure operating healthy of transformer. When all manufacturing process have been completed, tests are performed on the transformer at the manufacturer's work to ensure the following purpose: to check that the quality requirements have been met and that the performance is within the tolerances guaranteed as per the specifications in the standards. I said IEC or BIS, whatever may be your requirement. To prove that the transformer meets the customer's specifications and design expectations, to obtain information useful to the user during operation and maintenance of the transformer. Let us have an equation and find out. EMF calculations of the transformer. As per the design calculations, the designer is more interested in volts per ton. EMF equation can be written as E by N. That means volts per ton is equal to 4.44, a constant, and Bm into A into F. E by N is a voltage per turn, which is the same in both primary winding and secondary winding. Is because of the same fluxes flowing through the primary as well as in the secondary. Net cross-sectional area of the core. Core cross-sectional area also we have to take into account. And the frequency of supply. The design of the transformer should match with the design with the frequency of the local authority. If in India it is a 50 cycles, if it is a USA it is around 60 cycles. All over Commonwealth countries are using the 50 cycles supply. Now hysteresis losses are proportional to flux raised to the form of to the power of 1.6, whereas the eddy current is a flux to the raised to the square. So the equation is also important. You can say losses are proportional to frequency. Sometimes it is frequency square. Losses are also proportional to the flux. maximum flux value of a BM. So if the flux is more, it losses also will be more. So all the parameters, we should be very thorough about that, right? Now, if this is a simple diagram and elementary diagram. Left side we have the V1, that is the applied voltage. N1 is the number of turns, and the right side we have N2, and V2 is this voltage you are getting it, and you have to connect the load at this particular point. And the dotted line shown is the mutual flux, right? The fluxes are generated in the primary and going to the secondary and interacting with the secondary coil also. So the mutual means same flux is going here and there. So for the same number of turns, the same voltage is the voltage will be depending on the number of turns ratio. This is the end of the part 5. Next module will be transformer testing. We'll continue with that. Thank you to all of you for the interest.